Good morning, everyone. We'll be talking about quantum electrodynamics, or in short, QED. It's going to be basics of quantum electrodynamics. So, quantum electrodynamics is a fascinating theory that describes how two tiniest building blocks of the universe, electrons and photons, interact with each other. Electrons are like little charged particles that carry electricity, and photons are the particles of light. So, in the world of QED, these particles follow the rules of quantum physics, which are like special set of instructions of how things work at the smallest scales. One of the most intriguing aspects of QED is that electrons and photons can talk to each other by exchanging photons. It's as if they pass messages back and forth, but instead of using words, they use photons. When electrons exchange particles like photons, sometimes something interesting happens. It's like a game of catch where when you throw a ball, you move backward a little bit. Similarly, when electrons pass photons to each other, they move in response, creating a push and pull effect. And now electrons usually try to stay away from each other because they have an electric charge. Like magnets, they repel each other. They get too close, but the exchange of photons can sometimes attract electrons to each other, and other times it can push them away too. This dance of interactions in what gives rise to forces that govern how particles interact in our world. Quantum electrodynamics allows scientists to understand, predict, and how electrons and photons behave, helping us comprehend the mysteries of electricity, magnetism, and light. It's like solving a puzzle to uncover the secrets of universe at its tiniest level. In summary, QED is a powerful theory that shows us how electrons and photons play and communicate with each other, creating the beautiful dance of particles that make our world work the way it does. It's an exciting branch of science that continues to amaze and inspire scientists as they explore the wonders of quantum realm. So this is like the basics of quantum electrodynamics, and we're skipping a lot of crazy math. So actually there are a lot of formulas, yeah, which which are used to make Feynman diagrams. So like I'm sharing my screen.
Ah, your screen is visible.
Is it? Yeah. So these are some of the Feynman diagrams. So just a second. Yeah. So an electron goes from here. This is an electron basically. It's an electron. Yeah. And this is an electron too. It's an electron too. Yeah. So when they come at this point, this is like the basic Feynman diagram. They exchange their photons.
Right.
That's how they actually communicate with each other. And as they come close, we know that same charges repel each other. So after getting repelled, they just go in different directions. So this is like the most fundamental, basic Feynman diagram. And each diagram represents one equation from quantum electrodynamics. And same happens here. So this one is a little bit different. So when an electron goes, like I told you, so this electron like throws its photons out, and later on it it just takes it back in. Yeah, and we know this
Right.
part is like basically just this part. So again, they exchange their photons over here. An electron is going. Yeah, same here. Yeah, basically nothing is happening over here. So this electron at this point giving out its photon, and later on over here it exchanges photon, and after that it gets its photon back like before before releasing its photon over here, it releases over here, so it gets it back. This is all about quantum electrodynamics.
Right.
So
There's one more thing I forgot to add though.
yeah,
When an electron and a proton or maybe any charged particle, when they are in motion, only then do they eject photons. Like when they're stationary, they don't eject photons, right?
yeah,
So
yeah.
photons,
Then there's yeah, yeah,
they
yeah, yeah.
they come from the kinetic energy,
Yeah,
right? And one more thing. So each particle has a spin, right? A quantum spin. So
yeah,
if
yeah,
it
yeah.
has an even spin, then it only attracts. If it has an odd spin, then it only repels unless it has a negative odd spin. Then it can both attract and repel. So
Yeah, yeah,
photons have a have a spin of -1. So that means that they can be used for both attracting and repulsing. So
yeah,
because of this, opposite charges repel and similar charges attract.
yeah. Okay. So like, can I
Yeah,
start
you
with
can
quantum
continue now.
chromodynamics now? Hello, can you hear me?
Yeah.
Can I start with quantum chromodynamics? Okay, so okay, I'll see.
Can you repeat that?
Can I start with quantum chromodynamics?
Yeah. Hello.
Hello, yeah,
You can start with the chromodynamics presentation now.
yeah. Okay, so quantum chromodynamics. I'll share my screen. Yeah. So in physics, we know that the smallest particles in our universe are is electrons. They're like electron, protons, and neutrons. But that's not true, actually. Later on, physicists found out that there's something like protons and neutrons are made up of. Though those are called quarks. Yeah. So
Right, yeah.
yeah. So in protons, so if I want to like if I want to tell you the like structure of a proton, then it's this. So it's in it's two up
That's two up
quarks
quarks. That's
and
yeah.
plus one down quark. And if you're asking what are these up quarks and down quarks, so these are basically there are six kind of quarks. So one is up quark, down quark, and charm quark. Just a second, I guess. Yeah,
Charm
charm
quarks.
quark, strange quark,
Yeah.
bottom quark, and top quark. So these are like six kind of quarks. So fundamental, like the most fundamental of them are these two, up and down quark. These basically make everything in our universe. So, and we know proton has a charge of positive charge. Yeah. So if I want to explain, then a quark, okay. So these are quark and these are charge. So a quark has a charge of plus 2 by 3 and down quark has a charge of minus 1 by 3. So according to our maths,
Mm-hmm.
yeah, so 2 plus 3, like 2 by 3 plus 2 by 3 minus 1 by 3 is equals to positive 1. So positive 1. Yeah, that's what we say. A proton has a positive charge, right? Whereas we take a look at neutron. So it's an up quark, down quark, and another down quark. So again, if we use the same table,
Mm-hmm.
neutron has a charge of 2 by 3 minus 1 by 3 minus 1 by 3 is equals to 0. It's neutral. So all the charges gets cancelled out and it's like nothing. And so there's something, so strong nuclear force, basically it keeps quarks together. So those strong nuclear force are gluons, right? And
Yeah.
and there are three kinds of bosons. So like W plus, W minus, and Z. Three. And there are like gluons mediate strong nuclear force, and there are like 8 of them. So it's get complicated. So I'll make a table here. So particles. And we can differentiate them in two types, matter and force. So some of them are matter and some of them are more like they're like forces. So they are fermions and these are bosons that we just talked about. Plus W plus, W minus, and Z. Okay. And these fermions can be divided into further two kinds, which are quarks. And these are leptons. So if I want to explain leptons, it's basically like these are made up of, these are not made up of quarks. These have no quarks, these kind of particles.
Right. So we're describing the standard particle
Yeah,
model here, right?
yeah. It's the standard particle model, but it's like explanation of those, each of those. And quarks, like if you want to give the most common ones, then it's protons and neutrons. And like there are four kinds of leptons, which are which is electron. These are made up of these are not made up of quarks. Tau, muon, and neutrinos. And when we come to
Awesome.
bosons, so bosons, like they are not particles, basically, they just emit forces. They're like forces. So again, these are like four kinds of bosons. One is photon, and they emit electromagnetic force. And other is W or Z bosons. WZ
Okay.
bosons.
What's WZ again?
Huh? They are like
What's
W and Z are like forces. They're like particles. They are particles, but they emit forces. W and Z, they're kind of particles. So these mediate weak nuclear force. So what we're talking about is like the four fundamental forces in our universe. So it's electromagnetic force, strong nuclear force, weak nuclear force, and then gravity. So then gluons, we know that gluons are the one those who keep uh, quarks together. Yeah. So glue like quarks are basically joined because of they're together just because of strong nuclear force, and gluons are strong nuclear force. And then gravitrons. So it's still hypothetical. I light over here. Hypothetical. And basically this emits gravity. And one special mention that a gluon or a quark cannot be isolated. Like one quark cannot, you cannot find anywhere in the universe because it's like they're always come in three, pair of three. So they cannot be isolated. If we try to stretch it, it's just like a rubber band. If we try to stretch and like isolate them, they just their force gets even stronger and we can't do that. Like if we want to pull them apart, we cannot do that. It's impossible. I guess that's enough for chromodynamics. So it's enough for this meeting. Bye.